In this section, we discuss global illumination or GI. Global illumination is a series of algorithms to make lighting in 3D renders more realistic and look closer to how light rays work in real world. Without global illumination enabled in the settings, we could only get direct lighting, the light that directly comes from a light source. But when GI is enabled, those light rays won't be killed off when they hit the first surface point on their way from the light source. Like real world, those light rays start to bounce back and forth from those surfaces, and as those light rays hit a surface, they arrive with illumination and color information from the last surface point that they hit. But with each bounce, they lose some of that energy, until using the Vary settings we tell the light rays to stop bouncing. Keep what I just explained in mind. Let's go to the scene and let's see what we have. As you can see, it's a fairly simple scene and it's going to help us go through the very basics of global illumination concepts very easily. I have a Vary light on the ceiling and that is our only light source in the scene. I have two cameras in the scene, and for the second one I have clipping planes enabled so we can see inside the room. Let's open up our frame buffer. In the first two render, global illumination or GI is disabled, so we are only dealing with direct lighting. And in the last two renders, GI is enabled, so we have both direct and indirect lighting. Let's select the render with GI off from our first camera. Now let's see how light rays function in real world. So first, the light rays are cast from the light source into the scene. Those light rays travel until they hit a surface, and based on how bright the light source is and how far is the surface from the light source, the surface gets illuminated. When a specific light ray hits a surface, obviously it can't continue its path and we are gonna have shadows. Right now the shadows are very dark. That is because GI is off and we won't allow our light rays to bounce back and forth between surfaces, and they get killed off as soon as they hit the first surface on their way from the light. But as I mentioned in the introduction of this lesson, in real world, light rays aren't going to be killed off when they first hit a surface. They are going to bounce back between surfaces and transform information between them. When we enable GI, we allow the light rays to have this realistic behavior. Now if I load the render with GI on, we can see the shadows are a lot brighter. So let's draw some light rays here and see how this realistic behavior is happening in real world. We focus on this desk and chair here, and you can imagine the same scenario for the rest of the scene. So the light rays are cast from the light source in different directions. Obviously, some rays hit the top of the desk and top of the chair, illuminate those surfaces and cast the shadows beneath them. Now let's imagine a light ray hits the floor near the chair and the desk. Now, as we know, this ray is going to continue to bounce, and let's say in its first bounce, it's going to hit under the chair and illuminate that surface a bit. It bounces from that surface again, and based on its vector, it's going to probably hit the areas with the dark shadows beneath the chair and therefore making the shadows a bit brighter. Obviously, with each bounce, the ray is losing some of its energy. One of the fascinating things about GI is what we call color bleeding. As I mentioned, those light rays carrying both illumination information and color information. Now let's clear out these drawings. Let's say a light ray is cast from the light source and hits this red wall. We have GI on, so we expect the light to bounce and hit another surface. Now, based on the surface properties, this light ray might scatter into several rays and each one would continue to bounce in the scene. Let's say one of these rays bounces back and hit the ceiling near the wall. This ray now has some color information and has picked some red color from the wall. And when it hits the next surface, that surface is going to be a bit redder compared to before arriving this ray. If I right click here on this wall and take a look at the pixel information, we can see the red value is almost twice the green and blue values. You might ask, if this ray is having red information, why it's not turning the surface into a pure or a bit more obvious red color? Because first of all, this light ray is losing energy at each bounce, and the receiving surface has some surface properties, or might have some surface properties, that might block some of that information. Here in this render, we can see all the surfaces close to the red wall are redder, and the ones close to the green wall, or the ones facing it, are greener. In this example, we use some lonely rays to explain how light functions, but in fact, for each scene, we are dealing with millions of rays, and that's why the renders are often takes a very long time. Now let's close our frame buffer and go to our render settings. Obviously in V-Ray, to enable global illumination and control its settings and its parameters, you have the GI tab, and you can check enable GI to get V-Ray to calculate GI for you. For starters, let's make sure the interface is set to default. Obviously, you can click on this button and change the UI to advanced or expert and reveal more options, but in this case, we only need the default options. The first thing you notice is we have primary and secondary engines. Primary engine is calculating the first light bounce, and secondary engine calculates subsequent bounces. And obviously you can use different methods like irradiance map, light cache, and brute force to compute those light bounces. Now let's see how V-Ray uses these primary and secondary engines. Let me go to the second camera with GI on render. Our main camera is about here in the scene. Now, in order to determine what is in the view, V-Ray casts the first rays from the camera into the scene. When a ray hits a surface, to determine whether that point is in illumination or in shadow, a ray which is called a shadow ray, let's use a black color for this ray, will be cast towards the light source. If there is no object or obstacle between that point and the light source, that point would be in direct illumination. But if there is an obstacle between that point and the light source, that point will be in shadow. Until now, we just determined the direct illumination, whether a point is in direct light or in shadow. Now it's time to calculate GI or indirect illumination. So let me just clear these drawings. The color I'm using here are for pure presentation and have absolutely no specific meaning or role in the calculations. Now, these green rays are cast from the camera, and when they hit a point on a surface, a sample will be created. That is what we call it, a GI sample. And let's imagine these samples are red. Now, from this point or sample, which we already have its direct lighting information, whether it's in direct light or shadow, the first primary GI engine comes to play and sends out a hemispherical burst of rays into the scene to gather information from the scene. So if a ray hits the green wall, based on the distance between the sample and the wall, that point will get some of that green color from the wall. And if another hemispherical ray or primary ray, let's say, hits the red color on the other wall, let's say that red wall is closer to the sample point compared to the green wall, now that sample point will gather more red compared to green. That's what the primary engine does. But we said that in real world, the rays are not going to be stopped when they first hit the surface. From the second bounce, the secondary GI engine comes to play. And from each primary ray, casts or bounces another ray, and that ray, which let's say is blue, will continue to bounce in the scene and transform information between points in the scene. The secondary engine will continue to bounce the rays in the scene and will stop based on the settings in the GI tab. So we can tell the secondary GI engines to bounce each ray for, let's say, 3 times in the scene. Obviously, the more we let the rays to bounce in the scene gets brighter and the final render would be more realistic. But as with each bounce the rays lose some energy, after a while they don't have any worthy contribution to the final lighting and rendering. So we can kill them off, and by doing so our render times will be more manageable and faster. Also, the first burst of rays, which is controlled by the primary engine, we can control how many rays it will cast into the scene from each samples in the settings window, which we'll discuss in the upcoming lessons. And we will discuss all of that and all of these engines and irradiance map, light cache, brute force in this section. Just wait for it. So that was an introduction to how light functions and what is direct and indirect lighting, what is GI, and how it works in V-Ray. From the next lesson, we start learning about different GI engines that we can use as our primary or secondary GI engines. See you in the next lesson.